Good evening, students. Today we will discuss about the correlation and regression. I hope all of you aware the concept of the correlation and coefficient or correlation and regression. Correlation is nothing but the relationship between two or more variables. In the same way, here we can define the term regression also. Regression is average relationship between two or more variables. Here we can give any example for the correlation coefficient and also the regression also. Here we can give the first example for the correlation coefficient. That means here you can use to find the correlation coefficient, or the example for the correlation coefficient is here we can take some price and supply, or price and demand, or height and weights, or rainfall yield, and so on. So now we can go for our slide. So the exact definition is correlation analysis deals with the association between two or more variables. So this is the definition for the correlation coefficient. So next we have some types of the correlation coefficient. Positive, negative, simple and multiple, partial and total, and linear and nonlinear. The positive and negative correlation. Positive correlation is nothing but both A and B are in the same direction. That means if one variable is increasing and the corresponding another variable is also increasing, means the given correlation is said to be positive. Otherwise, it will be negative. You can give any example for the positive and negative correlation. In the same way, we can represent or we can define simple, partial, and multiple correlation. Simple correlation is nothing but only two variable relationship, or here we can measure only two variable relationship, that is simple correlation. Then multiple correlation means more than two variable relationship. Partial correlation is nothing but we can measure more than two variable relationship excluding some other variables. And also we have one more types, that means total correlation. Total correlation is nothing but all the facts are taken into an account. So the next one is methods of studying correlation. These are the methods to measure the correlation coefficient, like a scatter diagram method or scattergram method, simple graph or parallelogram in the graphical methods. So in the mathematical method, we have four cases. The first one is Pearson's correlation coefficient, then Spearman's rank correlation, then coefficient of concurrent division, and also method of least square. So these are the examples for the positive, negative, and no correlation based on the scatter diagram method. So the next one is simple graph. Here you have to plot the x and y on the graph sheet. You can get the some graph value. So with this here you can represent the relationship between the two variables, like variable 1 and 2. Here we have some values for the variable 1 and 2. So the next one is some example problems to solve the correlation coefficient by using Pearson's method. So the general formula is correlation coefficient R equal to covariance of x comma y divided by square root of sigma square. That means sigma x square into sigma y square, square root of sigma y square. For this question, here you have to find the x square value, y square and xy value. Finally, you have to find the sum, that means the total. Summation x, then summation y, summation x square, summation y square, and also summation x into y. Next, we have to find the x bar and y bar based on these results. Finally, you can get the R value. Here R is 0.95. So plus 0.95 means this is positive correlation, right? So the next one is rank correlation or Spearman's correlation. To find the rank correlation, here we can use the notation rho. The pronunciation is rho, R-O-W. Rho equal to minus 6 into summation d square divided by n into n square minus 1. So here d means deviation, n means number of paired observation. So next we have some example for the Spearman's correlation. So the next concept is regression. So already know very well for the definition of the regression or meaning of the regression, average relationship between two or more values. Or here we can use the exact definition is regression is a measure, the measure of the average relationship between two or more variables in terms of the original units of the data. So these are the difference between the correlation coefficients. So next concept is regression line. So to find the regression line or regression equation x on y and y on x, we have some formulas, general formula, x minus x bar equal to bxy r into sigma x divided by sigma y into y minus y bar. Similarly, the regression line y on x, or here we can use regression equation y on x. The general formula is y minus y bar equal to r into sigma y divided by sigma x into x minus x bar. So this is the example for the regression. Here we have some data, particulars, mean price value for this Chidambaram. Similarly, mean price for the Chennai, then standard deviation for the Chidambaram and standard deviation for the Chennai. So in general, the notation for the standard deviation is sigma. Here you can use sigma x and sigma y. Similarly, here mean means x bar. Here you can use x1 bar and x2 bar. Already the correlation coefficient, that means R is 0.8. You have to substitute all the values in the regression line x on y. Finally, you can get x minus 67 equal to 1.1 to y minus 72.8. When y equal to 70 means here you can get x equal to 72.6. So these are the basic things or basic ideas in the correlation coefficient. I hope this is enough for this class. Thanks for watching. Thank you very much.